In 1985, Bernard Eastland applied for patents that could make some of these ideas real. Many claim that these patents have become the blueprint for HAARP, High Frequency Active Auroral Research Program.
ARCO originally approached me in 1984 to find a use for the natural gas on the North Slope of Alaska, which they could not sell. To give you a feel for how much gas they asked me to find an application for, it was enough gas to produce all the electricity in the United States for a full year. I originated some ideas for military applications and beneficial civilian applications in which that gas would be converted into electricity and then used to power some gigantic antennas. Applications discussed in the patents included destroying missiles. Communications control and disruption were included. There were some other ideas both to possibly modify weather and finally to lift a portion of the upper atmosphere further out into space. It is possible with a big beam to take a part of that upper atmosphere and push it out further, where hopefully it would be able to deflect missile trajectories. What I'm holding in my hands is an electrodeless lamp. In it, I have a low atmosphere gas, somewhat similar to the atmosphere above the Earth. I'm now going to put this in the microwave oven, which will irradiate it with about 1 watt per square centimeter. And you see all of the motion of the plasma. That's typical of what will happen at high altitude where the ionosphere gets irradiated with these big beams.
That was 1 watt per centimeter. HAARP focuses 3.6 million watts and squeezes it into a billion-watt or gigawatt beam.
This was the planning document that really brought HAARP into being, and the absolute requirements ran from 1 gigawatt, which is a billion watts, all the way up to 10 billion watts of effective radiated power with a desired level of 100 billion watts.
At its biggest size suggested, if you beamed it for an hour and a half, that would equal the energy in a hydrogen bomb. What's the power when it pulses? And I can't find that in any of the documents that I've looked at. If you have a very small battery, you can put it in a small pen light and turn it on and have for some time a little bit of light. You can take the exactly same battery and put it in your camera, and when you flash that camera, the light will blind you. The nature of radar and these electromagnetic supplies is they can usually be pulsed. So one very good question for people to ask is, what is the peak power of that antenna when it pulses at its full capability? To make it bigger, all they'd have to do is add additional elements. In fact, the request for proposal specified a design that could be added onto.
The first module is what's called a developmental prototype, and that's 48 antennas in a 6x8 array.
The scientists point out they can make these ELF waves penetrate the Earth and get an image when that comes back. When I did this in '85, that kind of capability did not exist. After I had actually left the program in 1987, one of the last communications I had with ARCO indicated that there had been a contract awarded for ionospheric warfare studies. The application described in the 1991 patent would be such that if anybody were to fire a missile from any direction, anywhere, to another point on Earth, it would intersect this relativistic layer and be basically exploded. As a scientist, you do like to be recognized for things you've done. And because I couldn't write to the press, I'm under ARCO confidentiality, I sent a letter to Lord Cook, the chairman of the board of ARCO, and received actually a very nice letter back complimenting me for my contributions and assuring me that they would inform the HAARP people of my contribution. If you read the patents, I was thinking of ways to use it defensively. One was as an anti-satellite device. You could make these electrons in space and hurt a satellite. That could be used either for offense or defense. We could hurt the enemy's communications while maintaining ours, and I was interested to note that that was one of the things said in the HAARP basic technical document.
In 1983, I did radiotomography with 30 watts, looking for oil in the ground. I found 26 oil wells over a 9-state area, and 100% of the time was accurate with just 30 watts of power beaming straight into solid rock. HAARP uses 1 billion watts beamed straight into the ionosphere for experiments. Picture these strings on the piano as layers of the earth. Each one has its own frequency. What we used to do is beam radio waves into the ground, and it would vibrate any strings that were present in the ground. We might get a sound back like, and we'd say, that's natural gas. We might get a sound back like, and we'd say, that's crude oil. We were able to identify each frequency. We accomplished this with just 30 watts of radio power. If you do this with 2 billion watts, the vibrations are so violent that the entire piano would shake. In fact, the whole house would shake. In fact, the vibrations could be so severe underground that could even cause an earthquake. Is what's happening to the ionosphere while it's being held 80 miles out into space by this high-energy beam. It's heating up. And all of the molecules in that ionosphere region are absorbing energy out of that radio beam. And if they pick the right frequency to push that plume out into space, that energy may discharge back out of the ionosphere, back down the radio beam, and strike the Earth. And it would be about 100 times the energy released out of a thunderbolt. And that's how much energy would be released. If you beam this radio wave into the ionosphere and you continually charge it up, not only are you sending energy into the ionosphere, but you're providing a path for energy to come back down out of the ionosphere. Once a solar tap is formed and the ionosphere actually discharges, the electrons and energy will come from all over the ionosphere to that one point, and it will strike the ground in a bolt that is 100 times greater than any lightning bolt imaginable. And it will not just strike one time. It will strike 30 to 40 times a second until there are not any longer electrons or energy to flow from the ionosphere through that tap to ground. But when it strikes the ground, it will vaporize the ground, the water, or whatever it happens to hit. Kind of like 3 or 4 Mount St. Helens volcanoes going off each second that bolt discharges. Now, admittedly, that's kind of far-fetched, but whenever you're doing experimentation and you're taking risks with large amounts of energy, you must responsibly look at the worst-case scenario. And that could be the worst-case scenario.